Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
Today, we're focusing on one of the most foundational and, frankly, one of the most destructive sectors of the global economy, the built environment.
That's right. We're talking about construction, infrastructure, all the things that go up, but eventually they have to come down.
And the scale of this industry is it's almost impossible to grasp.
Oh, absolutely. It represents something like 13% of global GDP, and it consumes nearly half of the world's raw materials that we extract every single year.
But the real question is, what happens when those buildings reach the end of their life?
Well, they slam right into that prevailing linear model, the one we all know, take, make, waste.
And when they're disposed of, they're just torn down. Efficiently, yes, but it results in what the industry calls fines, this incredible low-value, mixed-up debris that's, almost impossible to recycle properly.
And that material stream, it's not a trickle, it's a torrent. The waste pile is immense. Just look at the U.S. numbers from 2015, 548 million tons of construction and demolition debris, C&D debris.
Wow, 548 million tons.
Mm-hmm.
To put that into perspective for everyone, that is more than double the amount of regular household garbage. Municipal solid waste generated that entire year.
It's a huge pile.
So, okay, we can't just keep digging holes for 500 million tons of debris every year. Where do we even start?
We have to move away from that linear model. We have to shift toward a circular economy.
Right.
It's a framework that's, by its very design, restorative and regenerative. It really rests on three core principles: designing out waste from the start, keeping materials in use, and regenerating our natural systems.
And that second one, keeping materials in use, that seems to be the critical part here. To do that, we have to completely change how we think about a building's end of life.
Exactly. We have to stop talking about demolition, which is just efficient tearing down, and start talking about deconstruction.
Which is what, exactly?
Deconstruction is the systematic dismantling of a structure. It's done specifically to recover the maximum amount of materials for reuse. And reuse is always the highest value strategy.
It is. And I think our mission for this deep dive today is to really explore the non-negotiable key to making this happen, especially in the commercial sector. We're talking about digital tools.
Yes, technology that can systematically document, track, and manage all these material assets, basically transforming every building into a transparent, valuable material bank.
Okay, let's unpack that. Let's start with the environmental case. Why go through all the complexity of deconstruction?
Well, urgency is all about carbon. I mean, despite U.S. diversion rates for C&D waste hovering below 40%, the real carbon advantage isn't from recycling low-value mixed junk. It's from high-value reuse.
Because you avoid manufacturing new products entirely.
Precisely. We have a really compelling example from Portland, Oregon that just illustrates this perfectly. They compared the carbon impacts of demolition versus deconstruction on single-family homes.
Right.
And the average deconstructed home resulted in a carbon benefit of 13.8 metric tons of CO2 equivalent.
13.8. And what about traditional demolition?
Only 6.2.
Wow, so less than half.
Right. And that massive difference, it comes from avoiding the energy to produce new stuff. And crucially, it keeps the carbon that's stored in salvaged wood locked away. It's not getting burned or just decomposing in a landfill.
And, that environmental benefit is now really starting to line up with the financial incentives.
It has to.
Right. I mean, landfill fees or tipping fees, they're climbing steeply. The national average is around $55 a ton. But in places like the Pacific states, it can be over $70.
So keeping bulky materials out of the landfill, it directly hits the bottom line. It starts to make the higher labor cost of deconstruction actually pencil out.
And there's a social benefit too, right?
Yeah.
The job creation potential.
Oh, it's a huge economic multiplier.
Yeah.
Studies show deconstruction generates something like 6 to 8 more jobs for every one job created by traditional demolition. You're building a trained, local, green workforce.
Okay, so that all sounds like a clear win for smaller residential projects. But commercial deconstruction, that seems like a whole different beast. You're talking about massive concrete and steel structures.
It is much more difficult. That is the central real-world challenge. The cost of labor and time is higher, no question.
So is it viable for, the average commercial property owner?
It can be, but the financial math only works when you factor in two things: the rising cost of new materials and the unique complexity of these buildings. A complexity that makes salvage impossible without good documentation.
What specifically makes them so hard to take apart?
It really comes down to timing and chemistry. About 60% of our existing commercial buildings were built between 1960 and 1999.
Okay.
And during that period, adhesives, epoxies, chemical fasteners, they became the main way to connect things, replacing simple screws and nails.
Ah, so instead of just unscrewing a component, you have to rip it out.
Exactly, which damages the material and basically turns it into those low-value fines we talked about. This chemical bonding makes systematic disassembly incredibly difficult. You can't see what you're dealing with.
Which means you absolutely need some kind of digital documentation to even know where to start.
Mandatory. You have to know the make, the model, and the attachment method of every single component to even attempt high-value salvage.
And that brings us right to the core digital tool here, the Materials Passport, or MP.
This is the single most important instrument for scaling this. You can think of it as the building's permanent, digital birth certificate, its maintenance log, and its exit strategy all rolled into one.
So it's a standardized digital data set for every component.
Yep. Describing what it is, what it's made of, and giving it value for its current use, and critically for its future recovery and reuse.
So the Materials Passport, it's solving that fundamental information gap. Without it, salvage contractors are just flying blind.
Completely. They don't have the as-built documentation. They can't see what's hidden in the walls or ceilings, so they can't bid on a project efficiently or guarantee the quality of what they pull out.
And that lack of transparency, it's not just an efficiency problem, is it? It's a major health and safety risk.
Absolutely critical. The MP is our frontline defense against contaminating the entire circular loop with toxic stuff.
Like laden asbestos.
Yes, the legacy issues, but also newer threats like HBCD flame retardants in insulation or certain VOCs. If we don't have transparent data to identify these substances, what are called substances of very high concern, or SVHCs, we risk contaminating whole batches of reused material.
So this is way more than just an inventory list. What are the key categories of information in a really good MP?
A comprehensive passport goes deep across 3 areas. First, chemical properties, composition, safety data, toxicity assessments, and proof of whether hazardous stuff is present.
Okay.
Second is the physical properties. This is what defines its economic and structural value. So tensile strength, weight, dimensions, and most critically, its expected lifetime, the reference service life, or RSL.
Let's pause on RSL for a second. Why does that change the game so much?
Because without it, a salvaged window frame is just used goods. With RSL documentation, a contractor can prove that this 10-year-old component has a tested remaining lifespan of, say, 30 or 40 years.
Right, so it's not scrap.
It's not scrap. It's a high-value asset. It completely transforms the resale price.
That's a huge insight. Okay, and you mentioned a third category, the instructions.
Yes, the process information. This includes how to install and maintain it, but most importantly, precise step-by-step instructions for disassembly and extraction. That's what's known as design for disassembly.
So if it's easy to remove, and we know exactly how to do it without breaking it.
Its reuse potential skyrockets, and it dramatically lowers the labor time during deconstruction.
Okay, creating a materials passport is a massive job. But for this to work at a citywide scale, that data can't just live on one file somewhere. It needs a whole digital ecosystem.
That's right. The data has to be machine-readable, standardized, and it needs to last for 100 years or more. And the core technology for that is building information modeling, or BIM.
The building's digital twin.
Exactly. It's where all that complex MP data is stored and linked spatially. BIM tells you what the material is, the MP tells you everything about it, and the BIM model shows you exactly where it is in 3D space.
It's the detailed blueprint.
It is. And to scale that up to a whole city, we use geoinformation systems, or GIS. If BIM is the blueprint for one building, GIS is the city's master map. It lets planners do large-scale material flow analysis.
So a city planner could look at a neighborhood slated for redevelopment and forecast, okay, in 5 years, we know we'll have 500 tons of high-quality steel coming online.
Precisely. It's an advanced map of the urban mine, and we're making it active now too, with IoT sensors that can monitor components and update their RSL in real time. And AI is being developed to help automate data collection from older buildings.
Now, once you have all this great documented material, you need a marketplace for it. And the salvage material market is notoriously fragmented.
Right.
How do digital tools fix that?
Well, digital marketplaces are popping up. Platforms like Reaply are being used internally by big companies like Google to track their own assets and prioritize internal reuse first.
Okay.
Others, like GlobeChain, are more like external resource exchanges where companies can list and sell materials.
And what about making it easier to find stuff at scale?
That's where aggregator models come in. The Circuit project, for example, developed a material reuse portal. It basically pulls in listings from multiple different platforms into one place.
So it makes it much simpler for a contractor to reliably find what they need.
It does. And the need for this kind of sophisticated tracking is so critical. Even a pioneer like Google ran into a very physical problem. They successfully salvaged these massive glulam timber beams.
Right.
They had the data, they got the beams out, and then they realized they had no storage space for them.
So they rescued the material, but then couldn't efficiently track where they put these 50-foot beams.
It just emphasizes why online registries like Magister are so necessary. They track the material passports to manage components not just chemically, but logistically over their entire life cycle. It stops valuable assets from just being forgotten in a warehouse.
So we have the digital blueprint, the MP, BIM, GIS. But these tools are only half the equation, right? You need supportive policy and industry standards to make it all work.
Without standardization, you can't measure anything. You can't set goals. We need standard data templates and circularity indicators, like the 37 key indicators developed by Circuit so cities can measure performance.
And we are seeing some cities build these requirements right into their regulations. Look at Palo Alto, California.
What are they doing?
They adopted an ordinance that requires a salvage assessment and mandatory deconstruction just to get a commercial demolition permit. It forces the issue up front.
And other cities are using financial levers. San Jose has a refundable permit deposit system. You only get your deposit back if you prove you've achieved their salvage target.
Which is pretty high, isn't it? Something like 75% diversion?
It is. So the incentive is a direct financial reward for doing it right.
And beyond just permits, cities can use their own spending power through public procurement, right? Forcing new government buildings or schools to use these principles from the start.
Yes, that drives market demand for the whole system. But operationally, the industry has to evolve too. Project teams have to require contractors to be salvage ready.
What does that look like on the ground?
It means integrating different techniques. You have selective salvage, where you meticulously remove high-value things like doors and light fixtures first. Then you have strip-outs. And finally, hybrid deconstruction, where machines help the manual crews.
So it's about being more precise and efficient.
Absolutely. Integrating these techniques is vital because it shortens the project timeline and, critically, it lowers the labor cost. That's what makes deconstruction truly competitive with just tearing the whole thing down.
You know, what really stands out to me in all this is the profound shift in mindset that this technology enables. Tools like the Materials Passport and BIM, they transition the built environment from just a polluting linear sector to one that's capable of systematic high-value reuse. It ensures every material can retain its value far beyond the life of just one building. It fundamentally redesigns building materials as assets, not as waste.
And I think the key takeaway for you, for the listener, is this. We are getting really good at developing these sophisticated digital tools. Material passports designed for disassembly, for future buildings. That's the easy part.
Right.
But the vast majority of resources, the truly immense untapped urban mine, is currently locked in our existing aging commercial buildings, especially those built before 1980, which have no digital documentation at all.
So the next great frontier.
The next frontier isn't just perfecting passports for new builds, it's deploying rapid automated systems like laser scanning, drones, and AI to efficiently inventory and unlock the massive undocumented material wealth that is literally all around us today. That challenge, inventorying the past, that's where the greatest short-term value really lies.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration?